In slope fields, you're putting together, well, not even putting together, are you? You're just kind of collecting. You're collecting slopes, little baby tangents all over the place. And in slope fields, you're approximating by following the flow. But in Euler's method, we're putting little baby tangents end to end to end to end to kind of trace, right? To kind of trace the curve, hoping to get, for some removal of space at a new x value, a much better approximation than the original tangent line would have been. So remind me really quickly, we wrote it down yesterday. You don't have to write it down right this second. But what does L equal, thinking about our book's notation with linearization? What does L equal?
Oh, it's f of x. I don't know what that is.
Don't do f of x because that would be general. Yeah, you could do f of a.
Plus a prime.
You mean f of a prime? F prime of a? And so you guys are so cute. We haven't even gone over the answers. We're just turning. Okay, that's cool. Sure. I thought it was A. I thought it was.
I didn't even know how to go about it.
We'll come back to it. Shh. Calm thyselves. Shh. Calm thyselves. The reflection does not need to be turned in right now. We are in our notes. We're going over Euler's method. Thank you for trying to be all amazing and on top of things. But long story short, I don't think we all aced it. So let's just wait to talk about it till later. Okay? Linearization, L equals, Y equals. You move the Y1 to the other side plus f prime of x minus a. That's a thing. We've done that. But that's not how it's going to look now. Because now, well, and this was used to approximate f of b. If you plug to approximate, if you plug b in. Does that make sense? This was used to approximate f of b when you plugged b into the linearization. True? Okay, so how is this changing? For Euler's method, first of all, we're doing a sequence of them. We're not just going straight to, because if we went straight to, it's the same thing as just using the tangent line. And you wouldn't be able to reevaluate the slopes and try to follow the curve with your little baby tangents end to end. So therefore, what you're going to do instead is you're going to end up at, after a sequence of starting at the initial f of x sub 0 is equal to y sub 0, you're going to end up at your f of, for instance, b. After moving through a sequence of, not a series, a sequence of steps where each and every time, I want to actually write something down there, so hold on. You're going to end up at your f of b, approximated by, after you go to your x1 and your x2, and however many steps, it depends what you're moving by as to how many of those in-between ones you'll have. But each and every time you're going to have to say, hey, for this tangent line, I'm going to use the point that I'm starting at. You always start at a point, go out a tangent line, start at a point, go out a tangent line, start at a point, go out a tangent line. I'm going to start at the previous point, so y sub 0, that's my f of a. Plus, I'm going to need a slope. That's going to be my differential equation at the previous point. And then I need my x minus a, which is just going to be, because every time these are going to be equal steps, it's just going to be my h, which is the same thing as my delta x, what I'm moving by. What I'm moving by. But then for the next one, I'm going to have to go ahead and reevaluate again. So now I'm going to go ahead and on this one, I get a y1, which is not the same thing as f of x1. It's just an approximation. But I'm going to go ahead and use y1 from right up above, because now I'm reevaluating. I don't have to get stuck on this tangent line. I can say, wait, what if this was on the curve? What would its slope be? What if this was on the curve? What would its slope be? And I get to trace the curve. Not perfectly, but at least a lot closer than it would have been on the original tangent line. So I would go again, y1 plus, and then I have my slope reevaluated at the last point with my delta x once again, and that'll get me a y2. And I continue this process until I arrive at the place where they wanted me to go. So this one says go straight to a point. All right, cool. But if it's way far away, if it's pretty removed, not even way far away, if it's pretty removed, it's not going to be a good approximation, but Euler's method is much better. And it's on the BC exam. So let's go ahead and try to do this guy. Euler. It's okay. Noah Lee spent the entire year last year trying to get me to say Euler. It was fun. Yeah. Nah, go ahead and just keep it in your notes. That's okay. I have another one for the back of your spiral. Okay, here we go. Ready? Where are we starting at? 0, 1. So I'm starting at f of 0 equals 1. And it equals because it's true. They gave me the point. That's definite. It's on the curve. Good to go. Now I'm going to go out from that point a tangent line. But to go out a tangent line to a new point, well, hold on. First of all, I have to figure out where I'm going. Where am I ultimately wanting to go? 4. So I could go ahead and, I like using f of 4. So I'm going to use f of 4. I want to end up at f of 4, but it's going to be an approximation because this whole process, as you guys saw, as soon as you go out from the initial point, you're a little bit off. I could take 4 jumps to get there. I could take 100 jumps to get there. So how do I know how many jumps I'm supposed to take and how closely or how quickly I'm supposed to be reevaluating? And they tell me a step size of 1. So I'm going to go to f of 1, f of 2, f of 3, f of 4. And all of these are approximates. But I can't fill it all in because I have to build. I have to go out a tangent line to a new point using the previous point. The previous point's analysis, I should say, of the curve. So the very first tangent line is built upon this point. Yes, I end up here, but I have to start here. So how do I start here? Well, hold on. Just think of this as L. It's a linearization. What do I need first? An f of, right? Do I need a y value? So can't I go ahead and use, for instance, y sub 0? Bless you, bless you. I'm going to do y sub 0 plus f of x sub 0, y sub 0, which is going to end up equaling, times h. There's an equals here because there's an approximate there. So it's okay, I'm just doing my approximation. What was the previous y value? 1 plus. What's the slope? Ooh, how do I do the slope? This is my differential equation, right? For y prime, so maybe it'd be helpful, if possible, to go ahead and say, oh, y prime is equal to y. That's a little bit nicer, right? So then plug in 1, plug in the y value, y sub 0. So 1 plus 1 times 1 equals 2. So I plugged in, I don't need an x. So I plug in my point, my x and my y. Oh, plug in your y. Okay, so y prime, or m, is equal to y. My delta x, or my h, is equal to 1. So my y value was 1 from before. My m, when I plug in my y value, was 1, and my h was 1. Now it's going to start getting interesting, because now it's going to start changing. Because now I'm going to go ahead and say, okay, let's go ahead and plug in y1, the y that resulted from this approximation, plus f of x1, y1. Well, let's make it specific. Hold on. What was your y1? 2. Plus differential equation now evaluated at 1, 2. y1, 2. Well, this one was evaluated at 0, 1. Using the previous point. I was using 0, 1 to plug into that differential equation. Now I'm using 1, 2 to plug into this differential equation. And who's my h? So we can make it particular. So 2 plus, what happens when you plug in? Oh, isn't that going to be 2 plus 2? Let me keep on going. Now it's going to be f of, what's my point? My h is staying the same the whole time. 4 plus 4. So at the end of the day, what's my approximation from Euler's method? Justin?
So when you do like the f of 3/8, you're just taking the 8 because the equation is y prime equals y.
But if it was y prime equals x plus y, well, be using everybody. Does that make sense? And it's allowing for the possibility of the first order differential equation being implicit. I think I said that right. Being implicit. This one wasn't bad because number 1, you were just plugging in whole numbers. Number 2, the slopes weren't fractional. And number 3, and they weren't very. Riemann sums. Do they ever ask you for n equals 20 on it? No. Did I ask one of those last year in homework? Yeah, but it's just because I wanted you to know the process really well. But no, they're going to have probably between 3 to 5 steps. Somewhere between 3 to 5 steps. Because 2 steps, I mean, that's kind of inconsequential. I've seen them do 3 and 4. I think I've seen them do 5. I don't think I've really seen them go any higher than that. But it could a little bit higher. And to that end, there is a one coming. But first, before the fun one coming, really quickly, what are some important things for you guys to realize as far as have present in Euler's method? Let me get actually the full highlighter. Equals the fact that every time you are changing what you're plugging in, and approximate. Because if you go equals to equals, you're going to lose points. Even if there's an approximate at the end. Because remember, the AP can take off points for things that are incorrectly stated even in the midst of the work. And so you have to have the approximates along the way. That was something pointed out at the conference a while back. Why? Because here's my function value being approximated by this work, which equals this, which equals that. But see, this approximate is still maintained. Yeah, good question. But remember, it builds on each other, and then even, I mean, I should do this, but I don't want to have too many highlighting, but yeah. It builds on each other as far as the y value, as far as what's being plugged into the differential equation. H stays the same, which is nice, but the approximate and the equals do need to stay different from each other. So what if, do I want to do that? To provide some context, not very much because I do want to get into section 7.2 today, but to provide some context, let me go ahead and do a page real fast. Guys, what is this an alternative to? Yeah, it's not an alternative to slope field because we're approximating like an actual value. Slope field's like, what's the trend? What's it look like, right? It's a little bit loosey-goosey, but within certain parameters. This is very precise in the sense that I want 1 point and 1 point exactly, approximately as best you can. So what would happen, what would have happened if we had tried just to do a linearization problem? Linearization, wouldn't we have just used the initial condition, right? So we would have had a differential equation evaluated at, which is just, right, times x minus, what would I have plugged in there? So my linearization would have been 1 plus 4 is 5. True? So tangent line would have said 5. My Euler's method says 16. And how can I know for sure how good I'm doing? That's awkward. How well I'm doing? Whether or not this is actually a better approximation or not? The only way to know for sure, actually I wish I could graph it, but if I graph a differential equation, that doesn't show me original unless I use some integration stuff. And how do I graph a y? How do I use my calculator to do a y? Could we? You would have to think about it. Yeah, you do dy dx and separation of variables and actually have to solve. But let's see how well we're doing and whether Euler's method was actually more effective or not. Just because I can do this one. Do you guys see how I did y prime equals y? I went ahead and solved it. Or I should say rearranged it. So I could do over y dx. Weird things have been happening outside my room all day. Okay, dy over y equals integral of dx. I would have ln, right? Let's see. ln always is. Even yet this year. Isn't ln always absolute value? But check it. Remember from last year? What happens when we do this? Right? And then what happens to our absolute value? We could make it a piecewise function, but yeah, ultimately it's like absorbed in the C. Gets absorbed in the C. It depends on the initial condition which we have. So the initial condition is going to be such that, what was our point? 0, 1, right? So we can go ahead and plug in 0. Anything 0 is 1, 1, oh. What are we trying to approximate? What is f of 4? Because we could solve this. E to the 4th, 2.718 to 1828 to the 4th. Between 2 to the 4th, which is 16, and 3 to the 4th, which is 80. Closer to 81. Long story short, how was 5 as an approximation? Terrible. Question number 2. How was, yeah, it is 54. How was Euler's method? But pause. Why was Euler's method still not very good? But not about the messages on the dum-dum wrappers. Anyway, so coming back. Got roasted a little bit, but it's okay. 16 is not 54. But why was Euler's method off too? I mean, tangent line, a distance of 4 is pretty far away, right? Like a tangent line, a curve pretty much immediately deviates. True, unless it magically comes back and then happens to hit the tangent line. But tangent line, okay, obviously that one's off. Why is this one off? Because it was like tracing. It was curving, right? Step size is 1. You went one whole one over, so it was already like deviating. Oh, hey, now let's reevaluate. Oh, hey, now let's reevaluate. And meanwhile, the curve is like swooping up. There it goes, right? So how could this have been an even better approximation? Go by 0.5s. Go by 0.01s. To make it easy. To see if you know the process, not so much to make it a good approximation. Yeah. Yeah.
So in the question, like, did they ask you to do Euler's method, or they ask you Euler's method and then find the actual point?
No, they probably wouldn't ask you to find the actual point just because this was a fairly easy differential equation. I wanted to at least somewhat solidify the process to you and what we're doing and how we're doing it, why we're doing it. I went ahead and showed you. Like, this is better, but the step size was high, so it still wasn't that great. But pause. Is the point of this for you guys to learn how to do by hand really tedious math over and over and over again? No, it's to understand the process so that one day maybe you could program it or understand the programming for it. Not literally as in you'll be using a program of Euler's method, but in the idea of, don't we have instruments these days that can do repeated tasks for us over and over again? So if we can learn the repeated task and if we can learn the programming, then we can maybe create something one day that needs to happen that hasn't happened yet. Anyway, Issa, you had a question. What was it?
Is it the higher the step size, the easier the problem? Is that what you just said?
Well, Riley was like, why would they give you a step size of 5? And I'm like, well, if it's nice and easy to plug into your differential equation, because the AP doesn't really maximize or focus on making the test hard for you by like increasing the numerical computations. That's not the point. They want the concepts, the calculus concepts, to be deeper. They don't necessarily want you working by hand all day on all this silly math. Does that make sense? Okay, so, ready? Set? Didn't you? Okay, this is called selective listening. Because I talked about Riemann sums and how on the AP, and last year I gave you one where n was like equal to 20. And then I talked about how the AP usually is 3 to 5, but don't worry, a fun one's coming. Come on, come on.
No, I just didn't want to hear it.
P.S. I'm going to try to do it by hand. I'll let you guys do it by calculator.
Wait, what?
Let's see what you can do. But you still have to do step by step. But if some of you guys, if you know programming or calculator, who knows what you could make. Jason Johnson made a program out of it. On your marks, get set, and go. Jason Johnson.
Miss Johnson.
Of course, Jason Johnson.
Okay, shh. We are not very effective with our time. And our work is a little when we're Okay. Focus. I'm going to get started because mine's by hand and you guys are allowed to use calculators. This is our iteration. Hold on. What do I want to do? There we go. Took a second. Well, you guys don't like that. Is that what you're not liking, the Y's?
Yeah, that's right. So I'm trying to refer to the other problem.
Okay. There you go. Is that better?
Yeah.
Okay.
Yeah.
Wait, what's wrong?
Wait, I thought you were like inside the brackets of that.
You have to use the X and Y.
To get to 10.
We're not getting to 10. We're doing 10.
Oh.
But we're going by 0.1, starting at 0. No, 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 no.
Yeah, that's
This is you having to connect. It was Y, so it was the 10th Y, but the 10th Y is going to end up at 0 going by 0.1s will be 1. Well, we have to do it somehow.
Well, no, you did 2 plus f of 0, 2 times 0.1. Can you just like put in the numbers of this one?
Yeah. I'm just showing so that if you guys get off, we can find, or if I get off, right? I need a whiteboard. Stop complaining. You can use a calculator. Shh. Or maybe we're just discussing, but either way. I should probably do this. Not equals. You guys still using approximate? Two. It's 2.63 times 0.1.
Oh,
There you go. There you go. Probably Euler. All right, Noah Leash. He made it on his calculator while we were solving. Probably not, but your step sizes wouldn't be as hard. Because it can be easily programmed, Maggie, does that make sense? And they don't give you things on calculator parts that could be easily programmed. Which is why anything to do with like a derivative or integral rule would not be on the calculator, because people could put their forevers and evers on their calculator.
Wait, that's. I'm sorry. Excuse me.
But it's not going to make a difference, because you're going to waste time and you're going to start relying on it, and then it's not going to be there when you need it because you can't use the calculator.
Did you know Hannah Lewis went to Power Program her calculator for Math 2 and decided to not take the test?
And then I canceled it. Too stressed.
No.
I
didn't think
It
of
was
that.
like
There's so
so
many area
bad.
formulas. Like,
No, I didn't use. No, they give you most of them. Like the ones you need.
No, but there's
There's a
of
lot
stuff,
more.
There's a lot in the app menu. You mean the ones that don't have apps to go with them?
I barely use my calculator. I just worked everything out by hand.
Well, I barely used my calculator and I got like a 7.40.
you understand?
No, it's actually.
Is this because you guys are all done and you're bored? Is that what's going on? Okay, shh. On which one? Uh-oh. I'm not lining up my decimals very good anymore. That's okay. Which one? You got mine?
Oh, have you put an equal? Wait. I got 3.7. Yeah, I got.
Except which one?
So 3.33 plus 3.33 times 6.1. That was 3.714.
Here?
No, I got the final answer. My final.
Oh, here?
No, for point 6. No, like
Oh, I haven't gotten my final answer yet. Sorry. I'm still here. I didn't line up my decimals nice. Yeah, 3.7146. Yeah. Maybe this will lead some of you guys to actually learn how to program. No, I just mean like in college. Well, there's not many classes in college you can use your calculator for, but we have to go to 1. But it's not hard, right? Not these days, not usually. Some schools still do. But
I'll feel close in your email.
And I feel like
It's so long.
I don't know, some of them are like, oh, consider it like early. You have to like decision within like
You see Davis stuff.
Davis does?
Maybe.
Oh, maybe.
I saw something on Naviance about them mailing something.
Yeah, all they do is mail.
But no, all the rest of the UCs are online. No, I want to just be able to like press it and be like, okay, time to go
I'm
and
scared
myself.
one
Like,
day I'm gonna go on Penn State, it's gonna be like,
Just so I'm scared to open the email and I just see either, oh, I'm sorry.
Congratulations,
Yeah, either
or-
congratulations
yeah.
or I'm sorry to inform you. I'll just have someone else. I'm scared.
I can just imagine like the day I opened mine.
Like having low expectations.
But you didn't even do ED anymore. You don't
I
get to do
know.
that. You lost that privilege.
I know.
I can't believe
I
she
did
did that.
regular decision last night at 11:30.
But it's in and it's done.
It's done. I never
No, but I saw her post, I'm like, oh my gosh, she decided to do ED.
I
And she's like, no, I did
said,
regular
no.
decision.
I don't need that stress in my life.
No, wait, does that mean I'm the only person who did early decision?
What? I wrote a lot of
Like, a
recommendations.
lot of people
Really?
did early action, but I don't know if anyone did decision.
Oh, yeah, I don't know about that
It was
one
just
either.
wasn't you. It was you were the only one I knew of.
Early action's so scary.
Why?
No,
Decision.
Oh, you mean decision?
no, that.
Oh, yeah.
If I get into school, this is where I'm going.
I mean,
started
I
waking
hate
up
to
at 3 a.m. every night.
I would
don't wanna
go,
do
but
this.
not a
I was
heartbeat. My
like,
issue is
so
just
bad.
money.
I just said no.
But like if I don't get financial aid, apparently using like appeal to like be released from it, so that's probably what my mom's gonna
But
do.
this is such a stressful thing, like, you have to go to school.
Yeah.
Yeah, like,
Yeah,
I
it
get it. It's a nice school, but that's such a.
No, I mean I kind of have a cop out just because how expensive it is.
But the thing is, it's not like you can just say it's too expensive. They have to look at your income and see,
Yeah,
like,
but
if you can't afford it, then.
No, like it
Yeah,
says,
just
it
say
says in
point
the
one
agreement
to
if you are not offered
1.0.
financially and you request it, you decide that you can't pay, we'll release you.
Yeah. Yeah, because you could have. Yeah. That's a good point. Me too.
So I got like 5.7.
That's what I said. I wouldn't use a calculator.
You're not using it. This is your mental math.
It's amazing what you can accomplish when you focus.
I thought you were gonna use like 1/10, but you were using actual decimals.
Mm-hmm. I thought you guys were gonna beat me by a lot more, though. Well, you guys did.
I had to erase it all because I put equal signs.
I did too.
Had to start over.
You started over.
Well, like I wrote Y1, 2, 3.
Oh. Yeah. See, Debo was throwing, so I just erased him. I was trying to show you how many steps we'd have to do. That didn't help you out a lot, though. Sorry. What am I on? 0.60. 7384303. Seven zero?
There.
I got 5.7. Oh, but you're on.
Okay, hold on. I was going and I was talking. Oh, that's the same thing. Plus 5.1 times 0.9 or plus 0.9 is 6.073, right? 6.073843073, yeah. 3018371 and 1 is 12 and 1. Oh, 11. Thanks. Of course, I make a mistake at the very end. We should sue. I lined it up wrong. 781.
Oh, I did not use all the.
Ha. So f of 1 is approximately 5.7.
So if I were to say I got like 5.8,
Mm,
did I get marked off?
Because you know that in 3 decimal places.
Well, I have
But hold on, the AP is not going to ask you to do a problem like this, because remember the point isn't, I said this a little bit earlier, to make the numerical hard. They want to make the calculus concepts hard, right? So they don't want to test you on your mental math abilities. I mean, they do a little bit, because if you're not good with numbers, you're going to make mistakes along the way. But
I didn't go all those decimal places. I went to like 4 numbers after decimal.
and then it went off.
Yeah, dude.
Well, it's going to make it go, yeah, because there's a lot of repetition, so like the error is going to compound as you go.
Yeah. Okay.
So I don't think you would need every single one, but you would probably need quite a few. How many did you keep, James?
I just kept 3 after, and I was off by the 1,000th place.
Okay. Oh, but by the 1,000th place? 10th to the 1,000th? It's pretty close. You would want to take probably, so like 5 should have been okay, 4 or 5. Pause. Doesn't make. Okay.
Your phone?
So guess what? Oh, look, I had a whole page of work to, oh well, I didn't use it. That's all right. I just did it all in there.
Wait, so
Section 7.1, do one. And it's homework number 25? Good. Sweet. Section 7.2. You sub.
Are you kidding me? Can we just nap for 10 minutes with Steve's Friday?
Why?
because
We're so behind. You sub.
Exhausted.
Is this homework due on Monday? No, so stop complaining. Okay, so you sub. Be tough. Mental toughness.
Mental, my psyche is shattered.
Who keeps calling you?
My psyche is literally been shattered.
Yeah. Yeah.
I have a missed call from them like every day. And I'm like,
1-800-733. I just ignore. 1-800-733. I just ignore. They gave up on me. They don't like my iron levels. Or they didn't. It's a 1-800 number. I don't think it'll work. Block the number. It's always the same number. Isn't it? 1-800-733?
no, mine is 909.
Oh. Maybe they changed.
Everything is wrong with me.
All right. So what would be chain rule for an f of g of h?
F prime of G and H. Wait, not even one school?
Riley,
It's just like,
be confident in you.
Hey, I gave up on trying to get I support you now.
but she
I'm literally trying to Michigan State.
So P.S. What's that equal? If she's somewhere cool, you can go visit her somewhere cool. What? There you go.
Everywhere is way cheaper than California. Yeah. Have you
Well,
New York?
not like NYU. Yeah, don't, but yeah.
I mean, living like tuition.
So what's going to be the integral of, wait a minute, this integral looks way harder than the integrals that we, right? Why? Because it's a chain rule, and chain rule back, well, it's going to look messy, and the answer is going to look hopefully nicer. Depends. But if you have an f prime of g times g prime, can't you just go straight back to f of g of x? Just don't forget your, oh dear.
Plus C. Plus C.
C.
Plus C. God.
But where is the u prime? Wouldn't my u be g of x? And wouldn't my u prime? Couldn't I rewrite this thing just to be the integral of f prime of u times du? That's how we make the connection. This one, f of g of h of x times g prime of h of x times h prime of x is equal to, yeah, of course, f of g of h, but here's the problem. With all that stuff, don't you think something somewhere simplified? And it doesn't look quite the same as it did when you first took the derivative? The dilemma. And so in this one, what would your u be? Well, your u would be g of h of x. Your u prime, or your du, technically is what we're doing now. Same idea as u prime, just in differential notation. would be g prime of h of x times h prime of x, which maybe you'll have and maybe you won't. But if you do have it, well, sweet. You could just make this the integral of f of u times du, sorry, f prime of u, du, which I could just go straight back to f of u. U substitution lets us take messes and try to figure out where they came from. Take simplified, I should say, take simplified derivatives and think about how to get back to the antiderivative without necessarily having to fully think through all of the in-between what had to have happened. Maggie, what's wrong, kid? No, it's okay, because you guys don't see this in integrals. You don't see this, but it's there. There are u's, there are v's. You don't see this. What you see is expression. You're like, okay, cool, let's go backward. What you don't realize is there could have been an f of a g of an h, and all that was derived, and then all that was simplified to be that nice little answer. So we use u sub to break it apart and to tear it down. This is a fun perspective from down here. Oh. Let Senora know. Yeah, but I didn't write it like that because I didn't want to totally freak you guys out. So, what's the integral of this guy? Yeah, don't make me your 2x. Doesn't this look like a u and a du? So couldn't this be in f of g of x, and that's a g prime? Could we go back to, oh, this is just going to be x squared plus 4 squared all over 2. Think about it, think about it, think about it. Don't just be overwhelmed. I'm trying to have you master calculus, which might be doing some more mental math than you were used to last year. This is a u, that's a du. U to the 1 came from a u squared over 2. It's a power rule. Could you have done the work that Maggie was trying to explain a second ago? Yes, you could. You could have made u equal to x squared plus 4. You could have made du equal to 2 over 2x. You would have seen that that would have canceled. You would have ended up with the integral of u du, which is u squared over 2 plus c. Or could you have distributed just a power rule and gotten some other nasty variation? I suppose. How about the next one? I don't know. It's up to you. I would say yes. I'm trying to show you that maybe with a little bit of practice you can do basic integration quicker than you used to. But you have to make sure that you're not making mistakes along the way. For instance, that u prime was perfect. This u prime is perfect, right? Has anybody gotten so far? This is just a u to the negative 2 du. And a u to the negative 2 du, can I just make that a negative 1 over? Because this to the negative 1, a negative 1 comes down, makes it positive, subtract to be a negative 2, and times u prime. X cubed minus 1. And some of you are still going to write this out every single time, and that's okay, but can your brain just look at it and say, oh, it's a u to the negative 2 du. Oh, sweet, let me integrate that. Like maybe your mental math jump is somewhere else, and that's okay. And this is also saying that, oh, hey, the du's are matching up perfectly. How often does that happen? Okay, so I'm not saying I'm going to be doing the integration in my head the whole time, but I do think we did last year, and we'll work on that Monday. Sound good? Finish up 7.2. Reflection. Oh, we're going to go over the answers. It was a hard Sudoku. I'll give you till Monday. I'm not going to put the grade in this grading period anyway.